All right, how are you guys doing? So today we're looking at day 9, and we're going to be doing lessons 34 through 37. So a lot of it may still be review and things that you guys know, which is great. If you don't know it or something you haven't gone over, then that's why we're going over it now. So lesson 34, and we're looking at decimal place value. Hold on. Gotta get my whiteboard up. Sorry. Here we go. So we're looking at decimal place value. So we've worked with decimals before, and we can write any number as, unless it's a whole number, we can still write it as a fraction or a decimal or a percent if we want to. But today we're going to be looking at decimals. So immediately to the right of our decimal number, our first is 1/10 or tenths, and then hundredths, thousandths, again with the th, meaning that it's less than one. So thousands, 10,000ths, 100,000ths, and so on. It follows the same pattern really as to the left of the decimal, except for we have a ones place for whole numbers. We don't have a one-ths place. It just sounds weird to even say for a decimal. So decimal to the right, we start with tenths, hundreds, thousands, 10,000ths, 100,000ths, and so on. Continues on into the millions, billions, trillions, and all of that, which would be a very, very, very small number. And then same thing to the left of the decimal. We have ones, then tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So it follows that same pattern. It's just now with a th at the end. So tenths, hundredths, thousandths. Okay. We use decimals a lot in money. So like a penny is 1/100th of a dollar, or we would say 0.01, or that'd be zero in the tenths place. So we don't say 0/10ths and 1/100ths. We would just say 1/100ths of a dollar. A mil, that's a term that you may see come up throughout the book. So a mil is a fraction, or basically a part of a decimal place. So if you've ever gone to a gas station or driven by, it might say, depending on the price, it might say 2.99 and 9/10ths, or 2.99 and 9 mils. Okay, so that mil is a fraction of a penny. So you see that right here. We have dimes are the tenths place. I know we have more currency than just dimes and pennies, but for place values, tenths. And then in the hundredths place, we have pennies. And then a fraction of a penny, we don't make any coins smaller than a penny, so we don't have an actual mil coin, but that would be 1/10th of a penny, or that would be 10th, 100th, 1,000th of a dollar. So if someone says they're giving you, what I guess would be 1,000 mils, okay, that would be $1. Okay, and then here we see our decimal point is kind of our anchor point, and then to the right, tenths, hundreds, thousands, and so on, as we mentioned. To the left, we know our place value is pretty good, 1, tens, hundreds. We can include the comma. It kind of visually helps us to make that distinguish into the thousands, 10,000s, 100,000s, then the millions, but we don't have to. So if we look at an example here, which digit is in the hundredths place? Well, hundredths, that th tells us that we are looking at a decimal place. Okay? And hundredths, so again, we just follow 1 to the right of the decimal is tenths, 2 to the right is hundredths, so the 5 would be in the hundredths place. Okay, so just look for that th. You might get in a hurry and say hundreds place, hundredths place, two very different things. If I give you, 5/100ths of a dollar, that's not super exciting. Whereas if I give you $500, that would be a lot more to celebrate. What is the place value of the 8 and 69.89 or 67 and 89 hundredths? Well, the 8 is 1 to the right of the decimal, so that would be our tenths place. Okay, practice that we'll do when we get to class. So working with place value. All right, lesson 35, writing decimal numbers and fractions and reading and writing decimal numbers. So writing decimal numbers as fractions, well, we just saw that we have all of our place values, tenths, hundredths, thousandths. So obviously, whatever numbers we have in those places, we could write it over. We have 2/10, we can write it as 0.2 or as a fraction, 2/10. And then in that example, we would be able to reduce it. So let's take a look here. So 3 of the 10 slots are filled. So that would be 3/10, which we can indicate with our decimal of 0.3 or 3/10. Okay? When we say it, really, we don't know if we're talking about the decimal or the fraction. I'll usually just say 0.3 or 0.3, just saves time and we know we're talking about a decimal. But, if you say this is 0 and 3/10 or just 3/10, okay, it's the same thing as this fraction. And then we see 3 of the 10 are filled. If we have 3/100ths, okay, so that'd be 0.03. Okay, then 3 of our 100 are filled in, so that'd be 3/100ths. So really, all we do is whatever place we're in, the tenths, hundredths, thousandths, whatever, we just put it over that number, over 1,000, over 100, over 10, whatever it is. And then we may have to reduce. So we've worked a little bit with reducing fraction. That's something that we'll do more and more of as we go on. So a quart is 0.25 gallons as a fraction. So if we go 0.25, well, this is tenths, hundredths. So this is 25 hundredths. And now, for right now, I know we're just getting in the hang of things, but this we can actually reduce down. So when we've talked about greatest common factor, or the biggest number that goes into both of these numbers, we know 5 goes into both of them, but 25 actually goes into both of them. So 25 goes into 25 once, 25 goes into 104 times. So we factor out 25 out of both of these and we're left with 1/4. So 0.25 as a reduced fraction is 1/4. Okay, but it was 25 hundredths as a decimal, so it's 25 hundredths as a fraction. And then we were able to reduce. Okay, down below here, reading and writing decimal numbers. We read numbers to the right of a decimal point the same way we read whole numbers, and then we say the place value of the last digit. As I said, for this example, just because it saves a little bit of time, I would probably say 0.23, or since we don't have to write in the 0, if we have 0.23 or 0.23, if there's nothing there, we know it's a 0. So a lot of times I'll just say 0.23. But the technical correct way to say it is we have 23, and then it's in the hundredths place, so we'd say 23 hundredths. Okay, this, we would say 20, and when we have this decimal, so 20 and 4, we don't say 0/10ths and 4 hundredths, we just say 4, because it's 0/4, and it's in the tenths, hundredths place, so 4 hundredths. If we have, for writing these as words, if we have an inch is 2.54 centimeters, use words to write 2.5. So we'd say 2 and, because we have a decimal right here, and then 54 hundredths. Okay, so 2 and 54 hundredths right there. And write out your 2, and you go ahead and write it when you're writing a word. So that tells us if we're reading this, that it's a decimal number, and then it's 54 hundredths. Okay. And then if we have the other way where we are working backwards from a written number, 15 and 2/10, we can write it in as a number. So we have one decimal place. The 2 is in the tenths. That's what's indicated there. So we would have 15 and 2/10. Okay, so practice set, we'll do that when we return to class. Lesson 36, subtracting fractions and mixed numbers from whole numbers. So again, we've worked with fractions. We need to have common denominators to add or subtract. But we don't always have a fraction, but we can write any whole number as either a fraction, an improper fraction, or a mixed number. And we'll show you how to do that. So if we have 4 right here, the server sliced one of the pies into sixths. So there was 6 pieces in this whole. It still makes up a whole pie, but it's divided into 6 sections. So we could have 3 whole pies and 6 slices of pie that make up 4 whole pies. So all that's to get you thinking, because sometimes when we add or subtract, we're going to have to use that information. So if I have 4 pies and I'm taking away 2 and 1/6, so I have 4 pies and I'm taking away 2 and 1/6. Okay, well, this is a mixed number. This is a whole number, but I can rewrite, as we just saw, we can call 4 as 3 and 1. 3 and 1 is 4, so we can call it 3. And then this is over 6, so I want to have my 1 in a fraction form that's equivalent to 1. And still over 6. So I know it looks kind of weird, 3 and 6/6. It sounds weird even to say, but we're doing that so that way then we can subtract this number. This is still equivalent to this. I haven't changed anything. I've just wrote it in a way, I've renamed it, so then I can perform the calculation. So just like decimal numbers or large numbers, whatever, we start from the right and work our way left. So common denominator. So I start with the fraction. I don't do 6 minus 6 down here. Okay, that would give us 0, and we can't divide by 0. So we just carry over that common denominator. Then 6 minus 1 is 5, and then 3 minus 2 is 1. And there's nothing we can do to reduce that. So we are done. Okay, so we're just renaming this or changing the form of it, so that way we can add or subtract depending on what we're doing with a mixed number. Okay, so if we have this example here, 5, now they show it here. You can do them vertically. When we get into more, multi-step problems, we're going to write out problems, more horizontally, just because if there's 2-3 steps to do that vertically, it would just throw us off and mess up the order of operations and everything. So I normally write it horizontally. If for right now you still feel comfortable writing it vertically like they did here, that's fine. Whatever. These are just one-step problems. We just subtract or add, and then we simplify if possible. But let's take a look at this one. 5 minus 1 2/3. Okay, so it's a whole number, so I want to make it a mixed number with a common denominator over 3. So 5, I'm going to take 1 away from this and make it 4. And that 1 I take away, I'm going to make a fraction that's equivalent to 1, but still over 3. So 4 and 1, or 4 3/3, which is equivalent to 1, equals 5 minus 1 2/3. Again, 3 minus 2 is 1, still over 3. And 4 minus 1 is 3. 3 1/3, can't reduce it, so we are done. Okay, practice that again. We'll go over in class. And then lesson 37, adding and subtracting decimal numbers. So we just talked about how to add and subtract fractions or mixed numbers. We talked about place value with decimal numbers. Now we're going to talk about adding and subtracting. So just like we line up any set of numbers, if it has 2 place values, 3, 4, 5, however many digits it has, we just line up all of the places, the ones, the tens, the hundreds, and then we perform the calculation. And when we get to the end, in this case, we won't have to reduce because we don't have any fractions or anything. We line up our place values, and then we just add them, carry any numbers that we need to. When we're lining up place values for decimals, the decimal actually makes it a little bit easier to line up place values. If you have a big, long 5-6 digit number or whatever, lining up all the place values for multiple numbers isn't too time consuming, but it takes a little bit of effort. Whereas if we have a decimal number, we just line up all the decimals. Okay, the decimal, 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 and then the decimal drops down here. That's going to line up our ones place, our tens, hundreds, thousands, and so on. It's also going to line up our tenths, hundreds, thousands, 10,000s, all of our decimal places automatically. Okay, so when we're adding, again, anytime we have a blank space, we don't have to, but we can fill in 0 just so we know it's nothing, which mathematically or numerically would be 0. So if we want to fill that in, we can. Okay, so we have nothing plus 1 plus nothing, so 1 in the hundreds place. 3 plus 4 plus 7, that's 14. So I put the 4 here, carry the 1 up here. Okay, just same thing as if we don't have a decimal number, we got to carry those numbers. 1 plus 2 is 3, plus 2 is 5, plus 1 is 6 in the ones place. And then nothing, nothing, 0, 0, plus 3 is 3. So let's look at example 2 here. Okay, so we line up adding or subtracting. So addition, this is similar to what we just did right there. If we're subtracting, we still line up the place value. So a gallon is about 3.78 liters. If she pours 2.3 liters of milk from a 1 gallon bottle, how much milk remains? So we're going to do 3.78 minus 2.3. 2.3. Again, it's 2.3, but I can still write that as 2.30. Same thing. Okay, my decimals are lined up, so it lines up down here. I start the furthest to the right. Okay, whether I'm adding or subtracting, whether there's a decimal or no decimal, we always line up our place values, and then we start from the right and work to the left. Okay, so I have 8 minus 0. Well, 8, take nothing away, is 8. 7 minus 3, 4. I already carried the decimal down, so that's done. And then 3 minus 2 is 1. So 1.48, and it was liters of milk remain. We'll practice that. We'll do a few of those in class. Okay. So that is it for this recording. Good job, you guys, and we will finish your homework, bring those questions, but also we'll go over this practice set problem for our next lesson when we return to class.